Bismillah ar-Rahman ar-Rahim. We'll continue. 4.1. That was the last one we did. So I have here what? Absolute maximum, absolute minimum. We know that if it's continuous on this interval. So now I check critical numbers. F prime at x is 6x squared minus 6x minus 12. Take 6 common factor, x squared minus 2. So it will be 6x minus 2x plus 1. F prime at c equals 0. That implies in c equal to or c equal minus 1. This belongs to the interval. And this also belongs to the interval. So I need to check f of minus 2, f of plus 2, f of minus 1, and also the endpoints, f of minus 2, f of 3. F of 2 will be what? 16 minus 12 minus 24, and that is minus 20. F of minus 1 is minus 2 minus 3 plus 12, and that is 7. F of minus 2 is minus 16 minus 12 plus 24, that is minus 4. F of 3, 2 times 27, which is 54. 3 times 3 squared minus 27. 12 minus 36. This is 63, so it will be minus 9. So absolute maximum minus, no, 7. And absolute minimum. Oh, so this is, yeah. This is small m. This is capital M. So m plus m will be what? Minus 20 plus 7, which is minus 13. Which is this one? Okay. Find absolute minimum, absolute maximum. I think they mean this. Values of the function this. So f is continuous. Very clear. Is defined, everything is defined. F prime. Derivative of the numerator, which is 1 over x times the denominator, minus the denominator times the numerator over x to the power 4. That will be x. I can take x common factor minus 2 ln x over x to the power 4, which is 1 minus 2 ln x over x cubed. I need f prime at c equals 0 to find the critical number. This is to find the critical numbers. That gives me 1 minus 2 ln c equals 0. That means ln c equal half. That means c equal e to the power half, or another was square root of e. A prime does not exist, x equals 0, which is not in the domain, or yeah, everything is, I mean, nothing in the domain where f prime does not exist. So I need to check f of square root of e, f of 1, f of e. F of square root of e is what? Ln square root of e, which is e to the power half. Which is e to the power half. Over e square root of e squared, which is e. That will be 1 over 2e. F of 1, ln 1, 0 over 1, that is 0. That will be ln e over e squared, which is 1 over e squared. I know in e squared is greater than 2e. So it means 1 over e squared less than 1 over 2e. So this is absolute maximum. And this is absolute minimum, since all values are positive. Okay. This is f is continuous. So for sure I have absolute maximum, absolute minimum. Let me do the calculations. F prime will be what? Minus 2x over 2 square root 1 minus x squared. This is plus half 1 over square root 1 minus x squared. So I can make it 2 square root 1 minus x squared, 1 minus 2x. Okay, f prime at c equals 0. So I have 1 minus 2c equals 0. So c equals half, which is in the domain. F prime does not exist, that means C equal plus or minus 1. Which are the endpoints? Which I will check. Don't need to. Okay, so f of half, f of 1, f minus 1. F of half is what? Square root of 1 minus 1 over 4, square root 3 over 4, which is square root 3 over 2, plus half sine inverse of half, which is pi over 6. That will be square root 3 over 2 plus pi over 12. This is almost 1. This is a point like 1 over 4, something like 1 over 4. So this is greater than 1. F of 1 will be 0, half sine inverse of 1, which is pi over 2. That give me pi over 4, which is less than 1. Negative 0 and half times minus pi over 2. That will be minus pi over 4. So this is absolute minimum. And this is absolute maximum. I think it's very clear. Find the absolute maximum, absolute minimum for this function if it's continuous on this interval. Yeah, I need to find the critical numbers here. Okay. Now find the critical numbers through f prime. F prime, I think we did it before. Let me do it again. 6 squared minus 6 minus 12. 6x squared minus x minus 2, which is 6x minus 2, x plus 1. F prime at c equals 0 implies c equal 2 or c equal minus 1. This is in the domain. This is an endpoint, so I will check it. F of minus 1, f of minus 2, f of 2. F of minus 1 is what? Minus 2 minus 3 plus 12. That is 7. F minus 2 is what? Minus 16 minus 12 plus 24. That is minus 4. F of 2, 16 minus 12 minus 24 minus 36 plus 16 minus 20. Very clear. Absolute maximum 7. Absolute minimum is minus 20. Okay, I think these are the questions in the last year. Like this is the interval, closed interval. So if it's continuous, in this closed interval, let me check f prime to find the critical numbers. F prime will be what? 12x cubed minus 12x squared. That gives me 12x squared times x minus 1. So I need f prime at c equals 0. That gives me what? X equals 0 or x equals 1. This is in the interval. Also, this one in the interval. So check now. F of 0, f of 1, also f at the endpoints. Let us see what will happen. F of 0, 0. F of 1, 3 minus 4, which is minus. F of minus 1, 3 plus 4, which is 7. F of 2, 2 to the power 4 is 16 times 3, that is 48 minus 2 cubed 8 minus 24. That give me what? Minus 24. Okay. Yeah. That's something wrong. F of 2, 2 times 4, 16 times 3, 48. Oh, not 4. This is 32. 2 to the power 3 is 8. 8 times 6, 32. That will give me 16. So capital M, 16, small m minus 1. This is absolute minimum. This is absolute maximum. So capital M plus small m will be 15, which is this one. If this is this, the sum of all of its critical numbers. First, what's the domain? Or real numbers. So no need to care. No, okay. F prime will be what? 2 cosine x minus or plus 2 sine 2x, which is 2 cosine x plus 2 plus 4 sine x cosine x, which is 2 cosine x 1 plus 2 sine x equals 0. Okay. So now let's check f prime at c equals 0. So I have cosine c equals 0. And that where? Oh, I have one cycle, one full cycle. That means c equal pi over 2 and c equal 3 pi over 2. And this is belongs to the domain, actually. Okay. And they have sine x minus half. Minus half means third and fourth quadrant. And the reference angle is pi over 6. So C, third, pi plus pi over 6, which is 7 pi over 6. And fourth is 2 pi minus pi over 6, which is 11 pi over 6. And this is belongs to the interval. Actually, I found them doing that interval. So the sum will be pi over 2 plus 3 pi over 2 plus 7 pi over 6 plus 11 pi over 6. That is 2 pi, and that is 18 pi over 6, which is 3 pi. So the answer is 5 pi. Oops. Which is this one? Okay. If the maximum value happens at x equal a, so a is the value of x where I have a maximum, and the minimum value is b. So b is the minimum itself. Okay. And this is similar to this question exactly. Okay. Because I find the critical numbers here. Okay. So let me do the calculation. Well, first, if it's continuous, actually continuous everywhere, so it's continuous in the closed interval, 0 to 2 pi. I found f prime, find the critical numbers. We find f prime with it. Yeah, I think it's the same. 2 sine x minus cosine 2x. Okay, and that is what? 2 cosine x. What is this? It's 2 cosine x. 1 plus 2 sine x equal to 0. So I have f prime at c equals 0. Give me c equal pi over 2, 3 pi over 2, 7 pi over 6, 11 pi over 6. Wow. Is it? Yeah. I need to check all of these values. And the Why do I solve this time? It's okay. F of 0, 2 pi. F of pi over 2, that's easy. 2 cosine pi. So, no, it's not that easy. It's 2 minus cosine pi, which is minus 1, that is 3. F of 3 pi over 2, sine 3 pi over 2 is minus 1, so this is minus 2. Minus cosine 3 pi, which is like, well, that's minus 1, that's minus 1. 7 pi over 6. So I cosine, that will be minus half. And cosine, I need to find cosine. If x is 7 pi over 6, cosine 2x is what? It will be cosine 7 pi over 3, which is first quadrant, which is half still. So it's minus half. That gives me minus 3 over 2. Okay. If 11 pi over 6 is what? 11 pi over 6. That is 11 pi over 6. If x equal 11 pi over 6, what will be cosine 2x? It will be cosine 22 over 6, which is 11 pi over 6. 11 pi over 3, which is the fourth quadrant, where the cosine is half. So this is 2 times minus half, which is minus 3 over 2. F of 0 easy. It will be minus 1. F of 2 pi, it will be what? It will be cosine, sine 2 pi 0, and cosine 4 pi is 1. So it will be minus 1. So where I have an absolute maximum is 3 at x equal pi over 2. And this is my A. Absolute minimum is minus 3 over 2 at x equals 7 pi over 6 or 11 pi over 6. But what I need B. So this is my B. So A plus B, you want A plus B, right? It will be pi over 2 minus 3 pi over 2, which is pi minus 3 over 2, which is this. You want to see how many critical numbers we have. What's the domain? For real numbers. Domain is R. So we do the derivative. F prime. Derivative of the first, which is 4 over 5. X to the power minus 1 over 5 times the second square. Plus the first. Derivative of the second, 2x minus 4. Now we take common factor, which is x to the power minus 1 over 5 times x minus 4 times what? 4 over 5, x minus 4. Here I have what? Plus 2x. Correct? X to the power 4 over 5. Good. And this one, 4 over 5. X minus 4 squared. Okay. That's good. So I have, here I have over 5. So I have x minus 4 over to the power 1 over 5. Here I have over 5. 4x minus 16 plus 10x. So that gives me x minus 4 times 14x minus 16 over 5x to the power minus 5. Okay, f prime at c equals 0. I have x equal 4, or c, I mean, or c equal 16 over 14, which is 8 over 7. If prime does not exist, implies c equals 0, and all of them belongs to the domain of f. So how many we have? 1, 2, 3. So I have the 3 critical numbers. Domain of f are real numbers. Okay. If the maximum value is a, then what? A is positive or negative, or who cares? Okay, let us check. First, f is continuous on this interval. Very clear. So check f prime. That will be 1 minus 1 over x squared. That give me what? 1 plus x squared minus 1 over 1 plus x squared, which is x squared over 1 plus x squared. F prime at c equals 0. Very clear, c equals 0, which is an endpoint. So I need to care about it. So f of 0 will be 0 minus 0, which is 0. F of 4 will be what? Will be 4 minus tan inverse of 4. I know from the graph that tan inverse of any value always less than pi over 2. So this is always positive. And this is the maximum. We call it A, so A is positive. So this is 0. Okay. Let f(x) equal this. And let m be the absolute maximum, small m the absolute minimum, find m plus m. Okay. This is f is continuous on this interval. So check f prime. That will be 3x squared minus 3x. Correct? Yeah. So I can take 3x, common factor, I have x minus 1. F prime at c equals 0. So I have c equals 0 or c equal 1. This is belongs to the interval. And this belongs to the interval. So I check f of 0, f of 1, f of minus 1, f of 2. F of 0, 0. F of 1, 3 minus 3 over 2. And that is what? 3 is 6 over 2 minus 3 over 2, 3 over 2. F of minus 1, that will be minus 3 minus 3 over 2. And that give me what? Minus 9 over 2. F of 2 will be 8 minus 6, which is 2. Correct? 3, 12 over 2, that's minus 6. That will be 2. There's something wrong. Minus 1, I minus 3. This is minus 1. Who cares? Minus 1. So that will be minus 5 over 2. F of minus 1 cube is minus 1. So this is absolute minimum. This is small m, they call it absolute minimum. Yeah. And this is capital M. So capital plus small, 2 minus 5 over 2, that minus half, which is this one. The sum of all critical numbers for this function in this interval. Okay. I need to check the domain of f, this one, because I have 4 minus t greater than or equal to 0. That means t is not equal to 4. So I need this interval. I'm working with this interval. So f prime of t will be square root of 4 minus t plus t 2 root 4 minus t times minus 1. And that will give me what? 2 4 minus t over 2 root 4 minus t. And that means what? I have 8 minus 3t over 2 root 4 minus t. Okay, so if prime at c equals 0, I see t equal 8 over 3, which is in the interval. Is that 3? It's okay. F prime of c does not exist. I see t equal 4, which is not in the interval. The domain of, which is not in the interval. So the only critical number is x equal t equal 8 over 3. So the sum, which is you have only one, is 8 over 3. The absolute maximum of this is what? Let me check if it's continuous in this interval. So check its critical numbers. F prime will be 1 plus x square square, x square square, 2x, which is 2x over 1 plus x to the power. I see c equals 0, which belongs to the interval. So check f of 0, f of minus 2, f of 1. F of 0, 0. F of minus 2, and this is arctan of 0. F of minus 2, that will be arctan minus 2 square, which is 4. And this is arctan of 1. If you notice, this is arctan. So this is 0. This is 1. This is 4. Very clear. This will be the absolute maximum. So this is arctan. Now we'll go to the exercises in the book. We'll try to finish them. Okay, let me do one by one. First, they said what? The value of the derivative at extrema. Find the value of the derivative if it exists at each indicated extremum. Number 5, very clear. This is the function. I can find the derivative. Number 5. F prime would be what? 2x, x squared plus 4 minus 2x times x squared over x squared plus 4 square. ده يديني what? 2x cube minus 2x cube مع السلامة 8x. So I have f prime at 0 will be what? Will be 0, which is very clear also. I have a horizontal tangent. Now 7, f of x is x plus 4 over x squared, which is x plus 4x minus 2. So it will be f prime will be 1 minus 8x minus 3. 1 minus 8 over x cubed. You want to check it at 2. F prime at 2 will be 1 minus 8 over 8, which is 0, still 0. Number 10. I know at number 10, the derivative does not exist. F prime at 0 does not exist. I have corner or sharp tail. We know it's sharp tail. Okay. Approximating critical numbers. What are the critical numbers? Here, very clear. I have critical number here, where f prime at 2 equals 0. And it is relative minimum, relative maximum, and absolute maximum. Okay, here we have critical numbers. Here, there, here. These are the critical numbers. At 1 and 3, 1 at x equal 1, at x equal 3, I have absolute maximum and the relative maximum. Very clear. And at x equal 2, I have absolute minimum and relative minimum too. Find the critical numbers. Now I need to do the calculations to find the critical numbers. Domain or real numbers are. So do 15. Find the derivative. That give me what? 8x minus 6. Make it equal to 0. Or that implies f prime at c equals 0 implies c equals 3 over 4, which belongs to the domain of f. So the only critical numbers I have is 3 over 4. 19. I need to find f prime. G prime at t will be what? Will be root 4 minus t plus t times 2 root 4 minus t times minus 1. And that will be 2 4 minus t over 2 root 4 minus t, which is equal to 8 minus 3t over 2 root 4 minus t. F prime at c equals 0 implies t equal 8 over 3, which is belongs to the interval this, because he was a restricted minus infinity to 3. But f prime does not exist, implies t equal 4, which does not belong to the interval, minus infinity to 3. So the only critical numbers we have is, yeah, give us this, okay, is 8 over 3. C equal 8. Okay. 19. What I have one cycle, okay. I have h prime at x, and the critical numbers would be 2 sine x, 2 sine x cosine x minus sine x. In other words, I can take sine x common factor, 2 cosine x minus 1. I need to check h prime at c equals 0. The function is defined everywhere, differentiable everywhere. We have no problem with that. That implies I need sine c equals 0 and cosine c equal half. When sine c equals 0, at 0 and by, okay, these are the critical numbers. Cosine c equal half, so c will be what? I have one cycle. Half means first and fourth quadrant. So I have pi over 3, and the reference angle is pi over 3, and 5 pi over 3. So I have 4 critical numbers. 21, f of t. What's the domain here? Domain or real numbers. We have no restrictions in the domain. Also here, the domain is all real numbers. So here, f prime at t will be what? E is minus 2t. Is minus 2t. Minus 2t is minus 2t, which is 1 minus 2t is minus 2t. If I make this equal to 0, that implies t equal half, which is the only critical number. So the critical number is t equal half. Belongs to the domain of f because the domain of f is all real numbers. 23. I need to differentiate. The domain is all real numbers because this is defined everywhere since x squared plus 1 always positive. So f prime at x equal to x log with the base 2 x squared plus 1 minus or plus x squared times what? X squared times this is 1, not 1. I don't know what is here. I have x squared plus 1 ln 2 times 2x. Derivative of x squared, so not just 2x. Okay. So that will give us 2x. I can simplify this. Ln x squared plus 1 over ln 2 plus 2x cubed over x squared plus 1 ln 2. In other words, I can take common factor 2x over ln 2. What's the remaining? Ln x squared plus 1 plus, I took 2x, so I have x squared over x squared plus 1. Notice this, always positive. So that means make it equal to 0. I have only x equals 0. So the only critical number, x equals 0. This page. More problems. Yeah. I have 16. The domain is what? From 0 to infinity. Let me write it. By the domain of f from 0 to infinity. So we'll find the derivative. That will be 1 minus 1 over 2 root x, which is 2 root x minus 1 over 2 root x. So I have g prime at c equals 0. That implies 2 root c minus 1 equal to 0. That implies c equal 1 over 4, which belongs to the domain of f. And g prime as c does not exist, implies that c equal to 0, which belongs to the domain of f. So critical numbers 0, x equals 0 and 1 over 4. These are the critical numbers. 18. F of x for x over x squared plus 1. Domain of f are real numbers. Okay. So I have f prime will be what? 4 times x squared plus 1 minus 2x times 4x or x squared plus 1 square. That will give me what? 4 minus 4x square over x squared plus 1 square. In other words, it's 4, 1 minus x square over x squared plus 1 square. F prime at c equals 0 implies c equal plus or minus 1. So the only critical numbers we have x equal plus or minus 1. 20. F of theta equal to secant plus tan theta. The domain of f is not between 0 and pi over 2. No. Secant is not defined at pi over 2. Yeah. I think, yeah, we need to be careful with this. The domain of f, yeah, it's okay. The domain of f is what? All real numbers. It's not between 0 and 2 pi. It's, yeah, it's between 0 and 2 pi. Between 0 and 2 pi. But I need to avoid these values where I have cosine is 0, which is pi over 2, and 3 pi over 2. Okay, so let me do the derivative. Need to avoid these values. F prime at theta will be what? 2 secant tan, and this is secant square theta. And this is what? That will be, yeah, I can take secant common factor. The remaining is 2 tan plus secant, which is what? Secant times 2 sine plus 1 over cosine, which is secant square. 1 over cosine is secant. 2 sine plus 1. Okay, f prime as theta equal to 0. That implies secant square equals 0, which is impossible, or sine equal minus half, which means when theta equal what? When sine equal minus half, which is pi over 6, but in the third and fourth quadrant, which is 7 pi over 6 or 11 pi over 6. Yeah, or 11 pi over 6. Okay, if I take f prime does not exist, then the function is not defined there. So the critical numbers are 7 pi over 6 and 11 pi over 6. Where theta equal this. Where theta equal this or this. Okay. Now we'll go to 22. G of x 4x squared times 3 to the power x. What's the domain of G? All in numbers. We have no restriction on G. So it will be G prime. G prime at x will be 8x times 3 to the power x plus 4x squared times 3 to the power x times ln 3. And that will give us 4x times 3 to the power x, where I have 2 plus x ln 3. So G prime at c equals 0. So I have x equals 0. This is impossible to be 0. Or x equal minus 2 over ln 3. So critical numbers, x equals 0 or minus 2 over ln 3. Okay, 22. What else? 24. G of t equal 2t ln t. Domain of G from 0 to infinity. G prime at t will be 2 ln t plus 2t over t, which is 2 plus 2 ln t. G prime at c equals 0. That implies 2 ln t equal minus 2. So ln t equal minus 1. That implies t equal e is minus 1, which is 1 over e, which belongs to the domain of G. So the critical number in this case is t equal 1 over e. That's the only critical number. Okay. Now we'll take some problems, how to find the extrema. And I think this is what we want, then quickly we can finish. Now we need to do this, which is a little bit lengthy, but I think it will be quick. This function lost all these functions are continuous in their domain. If it's continuous, except 37. Huh? Yeah, let me do it one by one. 25. If it's continuous in this interval. Okay. So in the first, I need to check f prime. F prime, it will be minus 1. So there is no critical number. So I need to check f of minus the endpoint. F of minus 1, if we check, it will be 3 minus minus 1, that will be 4. And f of 2, it will be 1. So this is absolute maximum and this is absolute minimum. Okay, 27. F is continuous on this interval. Check F prime, H prime, actually it's H prime of X will be what? Minus 4X. Critical numbers, minus 4X. I need H prime at C equal to 0. So I have C equals 0. So now I need to check F at 0, F at minus 1, F at 3, check which is bigger, which is smaller. F at 0 will be 5. F at minus 3 will be what? 5 minus 18, which is minus 13. F of 1, oops, F of 1, F of 1 will be equal to what? 5 minus 2, which is 3. So we have absolute maximum 5, absolute maximum 5, and absolute minimum minus 30. Okay, now we did 27. 1, 2, 3, 4, 5. كثير 16 مثلا. Okay. 29. I have f prime at x equals what? Or first, I need to say if is continuous in this interval, which is continuous actually everywhere. It's a polynomial. Continuous on this interval. They need to find f prime at x, and that will be what? 3x squared minus 3x, which is 3x, x minus 1, f prime at c equals 0. That implies c equals 0 and c equals 1 belongs to the interval. So we'll consider them. And the f at 0, which is 0, f of 1, which is 1 minus 3 over 2, that is minus half. F of minus 1, that will be minus 1 minus 3 over 2, that is minus 5 over 2. F of 2, that will be 8 minus 6, which is 2. So this is absolute maximum. And this is absolute minimum. Oops. This is absolute minimum. Okay, 31. How was it? If it's continuous in this interval, actually it's continuous everywhere. Cubic root, which we have no problem with it. So we need to find f prime at x, which is what? 2 x is minus 1 over 3 minus 2 is what? 31. And that will be what? Take 2 common factor. I have 1 cubic root of x minus 1, and that will be 2, 1 minus cubic root of x over cubic root of x. Okay. So I have f prime at c equals 0. That implies c equals 1, that implies, let me do the details, 1 minus cubic root of c equals 0. So c equals 1. It's an endpoint where I will check. No need to do it again. F prime at c does not exist. That implies c equals 0. So I need to check f at 0. This belongs to the interval. I check f of minus 1. I need to check f at 1. F at 0, the function is what? 3x continuous 0. F of minus 1, that's a square, so that will be 3 plus 2, which is 5. And f of 1, 3 minus 2, which is 1. Very clear, this is absolute maximum. And this is absolute minimum. Okay, now let me go to the next one. 33. Oops. What is 33? 6x squared over x minus 2. Equal to f. We call it g. 6x squared over x minus 33. Yeah. Interval minus 2 and 1. G is continuous. I need only x not equal to 2, which is not in this interval. It's continuous in this interval. F prime or G prime will be what? 12x times x minus 2 minus 6x squared over x minus 2 squared. It's 33. That will give me what? 12x squared minus 6 squared, that's 6x squared, minus 24x over x minus 2 squared. That will be 6x times x minus 4 over x minus 2 squared. G prime at c equals 0. So I have c equals 0 or c equals 4. This is not in the interval, so I will not consider. This is in the interval. So we are okay. At 2, the function is not in the interval. G prime at c does not exist. Actually, it's not the domain, the full domain. So it implies c equal to, which is not in the interval. Okay, so I need to check. Seems another that means I have what? G. Wait a minute. I need to find G at 0 and G at minus 2 and G at 1. G at 0 will be 0. G at minus 2 is what? 624 over minus 4, that is minus 6. G at 1, 6 over minus 1, that is also minus 6. So I have absolute minimum minus 6 at 2 different values, and absolute maximum 0 at x equals 0. 34. I'll do 34, which is t over t plus 3. I hope it will be t over t plus 3 over this interval, where h is continuous in this interval. Okay. Now h prime at t, let me do it quickly. That will be t minus 3. So it will be t equal minus 3 over this. That will be what? T plus 3 minus t over t plus 3 square. In other words, 3 over t plus 3 square, which is No critical numbers. Why no critical numbers? Yeah, because 0 cannot be, and no critical numbers. No critical numbers. So I need to check f at -1 and f at 6. F at -1 will be -half. F at 6, 6/9, which is 2/3. So that will be absolute maximum. And that will be absolute minimum. And this is 34. Now we'll do 35 and then 37. 35. What is it? Y equals 3 minus absolute value. Y equals 3 minus absolute value. T minus 3. He put T, صح? Yeah. Interval -1 and 5. 35. The function is continuous in this interval. This interval. Okay. So to do that, I need to find the derivative. So if I write y as 2y, 2 is, where 3 is the point where I have, it will be 3 minus t, not if t between -1 and 3, absolute value t minus 3 will be 3 minus t. If t between 3 and 5, absolute value t minus 3 equals 3 minus t. Oh, the opposite. Oh, yeah, this is t minus 3. Yeah, t minus 3. Okay, so this is 3 minus t, if t between -1 and 3. And this is if t between 3 and 5. It's 3 minus t minus 3. So y would be what? T. Y. It will be t in this case, this interval. And in this one, it will be 6 minus t. It will be 6 minus t in this case. The equality, you can put it here or there. There's no problem at all because the function is continuous at 3. So now we need to check y prime. So y prime will be 1 if t is between -1 and 3, and -1 if t between 3 and 5. واضح f prime at c does not exist if c equals 3. Okay. So now we need to check. So this is give me a critical number here. E equals 3. So I need to check f at 3, which is 3. And then f at the endpoints, f of -1 will be what? 3 minus 4, which is -1. F at 5 will be 1. 5 minus 3, 3 minus 2, that is 1. So this is absolute max, and this one absolute min. Okay. Now next one, last one in this group, 37. 37 f of x, guess integer of x, and this interval. Connect. Yeah. Here the function is not continuous, so I cannot apply what we did before. However, I can graph the function, which is easy to graph it. I have it at 0, it's this, then open, then this, then open, then this. This is 0, this is 1, this is 2, that's it. And then this is open, this is here, -1. This is -2. Also, if at 2, I have it 2. This is 2. Yeah. So for sure, from the graph, I have absolute maximum is 2 at x equal 2, but absolute minimum is -2 at any x between -1 and -2, or -2 and -1. Yeah, 2 -2. Between -2 and -2. Small. Okay. So we cannot do it. We can do it by the with the graph, but the function is not continuous. Okay. Now let me do 39. I know we have, but the same idea, but I'm trying different functions. 39. The function is continuous here. If it's continuous. Actually, I can say all of these functions are continuous. So I don't need to say it. So I need to find y prime. Let me do it quickly. That's -3 sine x equal to 0. So that implies x equal what? 0 is in the interval at the end point, 2 pi is in the interval. So I'll take pi. Okay. Actually, when we say f prime at c equals 0, that implies c equals 0 by 2 pi. But to check, I'll take this only because 0 and 2 pi are there in the endpoint. So I'll check it as an endpoint. F at pi, f at 0, f at 2 pi. F at pi will be -3, f at 0 will be 3, f of 2 pi will be 3. So what is the absolute maximum? This is absolute maximum at 2 different values, and that is absolute minimum. Very clear. 41. F of x equal arctan x squared, and this is the interval. So f prime will be 1 plus x to the power 4 2x. F prime at c equals 0 plus c equals 0, which is the interval. So I need to check f at 0, which is 0, f at -2, which is arctan 4. Also, I can't do something here. I can call this arctan 0. And f of 1, which is arctan 1. And I know that the arctan is something like this, where this is 0, and this is 1, and this is 4. So absolute minimum is 0, and absolute maximum is arc tan 4. Okay. That was 41. Okay. Now we'll go to 43, which is with the exponential. 43. I need h of x, which is continuous. H prime will be 5ex minus 2e to x. And that can take ex common factor. The remaining is 5 minus 2ex. Now we'll say h prime at c equals 0. This cannot be equal to 0. So I have 5 minus 2ec equals 0. So I have ec equal 5 over 2. Take ln, that implies x equal ln 5 over 2. Okay. Now I need to check the numbers. Yeah, I think we need the calculator in this case, which is very complicated. Yeah, what is the interval? Minus 1 and 2. So I need to check h at ln 5 over 2. That will be 5 e ln 5 over 2 minus e 2 ln 5 over 2. That will be 25 over 2. Okay. 25 over 2 minus 5 over 2 square, which is 25 over 4. That's 25 over 4. Okay. H at minus 1 will be what? 5 over E minus 1 over E square. Not easy to do. Not easy to compare to this one, I think. Yeah. Which is what? This is, I can rewrite as 5E minus 1 over E squared. 5, yeah. Cannot reach this one. I think 25 over 4 will be the maximum. Yeah. This will be the maximum. This is absolute maximum. Okay. Let me check the last one. H of 2. That will be what? 5E squared minus E to the power 4. Very clear, this is negative. So absolute maximum, 25 over 4, and absolute minimum is 5e squared minus e to the power 4. Okay, let me do the last one, which is 45. Y equal ex sine x, the last one in this group, huh? Between 0 and y. Okay. So what will be y? A function is continuous with relation. Y prime, oops, what happened? Y prime will be what? Ax sine x plus ax cosine x. And that ax sine x plus cosine x. I have y prime is equal to 0. So I have sine c plus cosine c equal to 0. That implies c should be in the third quarter, 3 pi over 4. I need to check f at 0. And that will be, I need to take f of 3 pi over 4 first. F of 3 pi over 4. And that will be e3 pi over 4 times sine 3 pi over 4, which is equal to 2 over 2. Okay. And f at 0 will be 0. F at pi will be 0. So this is an absolute maximum for sure. And this is the absolute minimum. Two different values. Okay. Now we'll do these problems. 40. 45, this is 40, the even one. Okay, no problem. Hopefully it will be easy to decide. Yeah. Between 0 and 2 pi, right? This is continuous in this interval. And this is also continuous. This is continuous. This is continuous. All of them, they are continuous in the interval. Huh? So now we need to check y prime. In this case, it will be what? Pi over 8 secant square by x over 8. Well, this one impossible to be 0. This is 40. Impossible to be 0. That means I need to check only the endpoint. No critical numbers here. Check f at 0. I mean, in this interval, impossible. Secant square actually cannot be 0. If it's 0 will be tan 0, which is 0. F of 2 will be tan pi over 4, which is 1. So this is absolute maximum. And this is absolute minimum. Yeah, easy one. 42. It's continuous. Now check G prime at X, which is, I think it's impossible to check it this time. Okay, let me check. G prime at X will be what? 1 over X times X minus ln X over X squared. That is 1 minus ln X over X squared. So G prime at C equals 0. I said ln C equal 1, so C equal E, which is in the interval. Now we'll check FE. That will be what? 1 over E. F of 1, that will be 0. F of 4, that will be then 4 over 4. All of these are positive, so this is the absolute minimum for sure. Now, which one bigger? 1 over E or then 4 over 4? Yeah, I think not easy to check. Not easy to conclude. Multiply by 4, E then 4 is what? Yeah. Actually, this is by the calculator, give me 0.347. And this one give me 0.368. So this is the absolute max, which I need the calculator to do it. 44. I have, as we said before, y prime is 2x minus 8 over x, which is, in other words, it's 2x squared minus 8 over x, which is 2x squared minus 4 over x. Okay. So check f prime at c equals 0. That implies in c equal 2 or c equal minus 2. This is out, not in the domain. So I have c equal 2, which is in the interval. So I need to check f at 2, and f at 1, and f at 5. This is the last group. F at 2 will be what? F at 2 will give me 4 minus 8 then 2, which is the negative value. F at 1, give me 1. Okay. If at 1, give me 1. If a 5, give me 25 minus 8, then 5. So very clear. This will be the absolute maximum. And this will be the absolute minimum since it's negative. That okay. Now let me go to this, which is the last one in this group. Function is continuous, blah blah blah. Y prime will be then x plus 3 plus x over x plus 3. Which is what? This is always positive, so this is always positive. Ln of 3. So this is always positive, this is always positive, so this is always positive. Impossible to be 0. So I check the endpoint. If at 0 will be 0. If at 3 would be 3, then 6, which is positive. So this is absolute maximum. And this is absolute minimum. Okay. Now let me move to this group of questions, which I think the best way to do it is through the graphing the function. This is an easy functions. So if you graph the function here, that's just a line, and just do it at 0 and 2. 0, I have minus 3. At 0 is minus 3. Let me do it like this. At 2, it will be 1. At 2, it will be 1. So we are talking about this line. Okay. Now let us take it interval by interval. This is 0, and this is 1. At 2, this is at 2, is equal to. Okay. So A, if I take the closed interval 0 and 2, so I have minimum minus 3, not minus 3, at the point 0 and minus 3, and maximum 2 and 1. Okay. Now if I take the point close 0, open 2, then I have only minimum. There will be no maximum because this is open. If I take the point 0 and 2, close at 2, I have maximum only, which is 2 and 1. However, I take the point, all of them open, no extrema. No extrema in this case. Okay. I think I have these 4. Let me do them quickly. 5, 6, what they want? 56. They won't use the computer graph to graph it. I will not do that. Use the authority to find any critical numbers. So he wants to find the critical numbers. And let me do it and find if they have any extrema. Let me do it calculation. The function is continuous. Actually, I have 3 minus x is equal to 0. That means x less than equal to 3, which is continuous here. Continuous in this interval. I need to find f prime. F prime will be what? Will be 4 over 3 square root 3 minus x plus 4 over 3x times 2 square root 3 minus x times minus 1. And that just I have make it 6 square root 3 minus x and multiply. Here I have what? Yeah. So multiply by 2 root 2, that will give me 8, 3 minus x, 8, 3 minus x. Okay. This one minus 4x. Okay. I think I did something wrong. This is 8. Yeah. I have 6 multiplied by 8. I have 8. Let me do it in a different way. واحد المقامات عاد على 1. مقام مشترك 6 square root 3 minus x over 3. This is 2. 2 times root, so it would be 8, 3 minus x. And this one will be what? Minus 4x. Yeah, let me do it. That will be 24 minus 8 minus 4 minus 12x. Yes, 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 that's correct. So I take 12, so I have 2 times 2 minus x square root 3 minus x. Great. So what are the critical numbers? I need to check f prime at c equals 0. That implies x equal 2, which is in the interval. And if prime does not exist, it means x equals 3. It's a critical number, but no need to include because I will check it as an endpoint. F at 2 will be what? 8 over 3. Square root 3 minus 1 is 1. Okay. If at 0, it's 0, f of 3 equals 0. So this is absolute maximum, absolute minimum, I mean. And this is absolute maximum. Okay. 65 and 66, what they want. Explain why the function tan x has the maximum in this, but not in this. Yeah, very clear. Tan 65. I know that tan is continuous on this interval. Or let me say between 0 and pi over 2. So for sure it has a maximum on this interval. But the limit as x goes to pi over 2 from left for tan x will be infinity. So no maximum on this interval between 0 and pi. We're included pi over 2, which is make it goes to infinity. 66. I need to decide where I have an absolute maximum, or each one of them. Is it an absolute maximum, absolute minimum? I have A, B, C, D, E, F, and G. A is an absolute minimum, very clear. B is a relative maximum. C, neither. D is a relative minimum. E is a relative maximum. F is a relative minimum. G is neither because it's an open. So neither. Okay, we're almost there. I want to do these problems quickly. He says, exercise, determine from the graph whether f has a minimum in the open interval. Here, yes, there is a minimum. Here, no, because this is open. So we have no minimum. And this one, this is open, so no minimum. No. And this one, yes, because this will be the smallest one. So this is yes. Critical numbers. Consider this function. Is x equal minus 2? Note, what's the domain of f? 69. The domain of f, all real numbers except minus 2. So minus 2 does not belong to the domain of f. So it cannot be a critical number. So the answer is no. Because minus 2 does not belong to the domain of f. 70. Create a graph in this interval minus 2 to 5. So we want to graph a function from minus 2 to 5. So what? At minus 1, it has a relative minimum at minus 1. So it will do something like this. And at minus 1, then it go back. At 0, it has a critical number, but no extrema. We can do something like the cube. Okay. We have function is not differentiable, like something like this, where I have, but it's okay. And then as an absolute maximum at x equal 2. So at x equal 2, I'll make it, this is the maximum, 2. And absolute minimum at x equal 5. I'll make this all the way down, make it like, who cares? But here, I will make it like vertical tangent. Huh? So the derivative is not, so the function is not differentiable. I want to make it, yeah. I want it to be vertical tangent here. Huh? Like the, yeah. Not like this, sharp. Sharp vertical tangent here, if I can graph it. So it has critical number at 0. So I have critical number at 0, but no extreme. No extreme. Okay. This is the last problems, true or false. The maximum of y equal x squared in the open interval is 9. No, this is wrong. This is false. Why? Look at this. You want open interval for x squared. So it's open here. Open here is minus 33. This is 9, but there is no maximum. So this is false. 76. If the function is continuous in a closed interval, then have a minimum in the interval. Yes, this is the statement. So this is true. If x equals c is a critical number, 77. He said x equals c is a critical number of a function. Then it's also a critical number of this function. Yes, c is a critical number. That implies in f prime at c equals 0 or does not exist. F prime does not exist or is equal to. Now check g at c, g at x, f of x plus k, or f prime does not exist. Now g of x equal f of x, so g prime at x will be what? F prime at x. So for sure, that implies إنه C is a critical number for G of X. So this is true. 78, G of X is f of X minus K. So if you find the derivative, or let me do it by an example. Let f of X equal X squared, where I know that X equals 0 is a critical number. Very clear, critical number. Now take G of X, f of X minus K, that will be X minus K squared. So what's the critical number in this case? If you put G prime, so I'm getting X equal K is a critical number. So this statement is false. This is true. Yeah, I think I will stop now. Yeah, this is the end of this section, 4.1. Let me just close the recording. Thank you.